Hello and welcome to this discussion about angle versus tube when it comes to food processing equipment. My name is Doug and I'm here with Chad and Steve from IME. So we're going to talk about angle versus tube in the food processing equipment. When you design a piece of equipment, you have a choice. Why would you use each one? The downfalls and the positives of each one.
First of all, we'd rather build it out of tube.
I would agree with that.
Yeah.
Why would you rather?
Well,
tube's the hardest.
aside from sanitary design, from a practical standpoint,
And a fabrication point of view.
we love it when we can just build it out of square tube because it's stronger, stuff holds better, it's more sturdy, right?
Tube is.
Yeah.
And
It's easier to cut and have square corners come together. And it looks good when it's done, usually.
yeah, but understanding sanitary design, and it's especially in the USDA meat packing plants, it's like a no-no. You cannot use square tubing. And so we have to rethink, we have to...
So in meats, you can't use square tubing?
Hardly at all. Even handrail is angle.
Oh, okay.
Right.
Okay. So tell me the difference now, because I always thought tubing was round.
It is.
So,
Yeah, square tubing, well, it's round and square.
Oh, okay. When you talk about tubing, then we're talking about square and round.
Square and round, yes.
Okay, and angle then is just a piece of metal that's angled. Oh,
Yeah.
cool.
And angle iron is a structure. So it's thin on the edge. It gets stronger in the middle. It's thicker, and then it goes back thinner. So it does have some structural. Angle iron does. What it's caused us to do, though, this very problem, like saying with a conveyor, this sanitary design, is we'll cut a flat pattern for legs, structure, members, and then bend it to give it strength. And so that's what's caused us to do that, so that there's not tube.
But the real problem with tubing, either square or round, is that it's hollow. Usually, I think I could say not usually, always, when something hollow leaves here, it will be completely welded, seal welded.
In my studies, that's what they said. If you use tubing in sanitary design, it has to be completely seal welded.
Seal
So
welded.
there's no pockets for bacteria. You can't collect
Exactly.
any moisture or anything like that.
Exactly. The problem comes, though, is you don't know what might happen down the line. Someone might change that piece of equipment.
Or drill a hole in
drill
it
a hole
to
in it.
mount an electrical bracket, or...
Oh, yeah.
Now you have a place for water to get in, and where there's water and food particles, then now you've got a perfect environment for bacteria growth.
We always say, well, we seal welded that. But the problem is we've done some demo projects where we'll demo an old deck that's got square tubing in it. And in these food plants, they'll use high pressure water. And I mean, they clean high pressure. It's 300 pounds of water, 300 to 600 psi of water on something. It's going to find the hole. And we've cut into some decks that water just come gushing out of the legs, completely full when we demo some equipment.
That's
We
kind of
found it.
concerning, though. Can you completely fill it? Is that possible so there's no leaks?
I'd say no. You can't guarantee it because you don't know what's going to happen down the line. As good as we are, it's possible to get a little pinhole
Yeah,
in a weld that you
Or-
can't even see,
a stress crack.
or a stress crack. There's something that could happen that would allow water to get inside that tube. And so the cure to that problem is just don't ever use tube. Just don't use it.
Just don't use it. So you can completely take it out of the design.
Right.
And that's tough sometimes when you're talking big structure too.
Because the angle is not as
Not as strong.
Not as strong. So how do you overcome that then? If you're going to use angle, because tube has the potential of having bacteria grow or water, things like that. How do you? And the angle's not strong enough.
Well,
Then what?
you fabricate something. So we either build our own I-beam. I-beams are strong. And a lot of times with stainless, that's what we have to do, is build an I-beam because you can't buy them.
Or we can use a channel iron.
Channel iron works good, yeah.
That's, a three-sided piece
Oh, okay.
that's got an open side, so there's no enclosed area.
Does the thickness of the metal make a difference?
Sure.
Yeah.
The thicker it is, the stronger.
The stronger it is. So how do you determine if you're gonna angle it because you know that's best for sanitation? But how do you determine the thickness then of the metal that you're gonna need and where to place it and how does all these components come together?
Well, kind of at this point, a lot of it's just experience, especially with conveyors, because we've built so many conveyors, we just kind of know what works. There are calculations. You can analyze material in a welded structure to make sure it's strong enough. And then we have software that helps with that.
We can run the calculations to see what kind of load it can hold, and if it needs to hold 1,000 pounds per square foot or whatever, we can factor that in the design and run the program to check it.
And so then it'll tell you use this gauge steel or
Well, you can see the weaknesses, so you'll add something here or there as an upraise or something like that.
So how does 3D design apply in this then? Because usually the tubing and the angle iron is for handrails, legs. When you're doing this with your 3D design, are you able to then take a look at that material and make it work, and then the customer can see it? Is that
That's correct. Yeah.
so? It'll tell you all the specs that you need in order to construct it, so it'll work for them.
Yeah, if you didn't have AutoCAD, the 3D software, it would be very difficult to design this way. You know, the old timers seen it on a print, and you know that's why they would build stairways out of channel iron and square tubing,
Big,
heavy stuff, and then they'd have to lay out every stair, you know, or a conveyor. They would just start with square tubing and build a frame and then put some bearings on it, and it was all
stand back and say, well, this might work.
yeah, well, we better change this or change that.
And the easy way to do it, really, is to just overbuild.
Yeah, overbuild it. Yeah, a lot of
Overbuild
stuff.
everything.
A lot of stuff got
But
overbuilt.
the problem with that is it just costs more.
So
The material costs
overbuild
more.
means they just
Made it really
Just
strong.
made it
it
so
was-
strong, there's no way it's going to fail.
Yeah.
but does not necessarily mean it's sanitary.
Oh no, it wasn't sanitary at all.
Two issues when it comes to sanitary is the surface in which the food actually contacts, and then the other areas like the legs and the handrails, stuff like that, where it doesn't necessarily come into contact, but it can also contaminate the food if it accidentally comes in contact, or somebody touches it and then
Yeah.
touches the food. And
Yeah,
I mean,
that's how it happens a lot. I think is by just people
Touching.
their hands touching one place and then touching another place.
We had an issue down at one of the plants that the floor drains covers were fabricated in a way where they weren't seal welded. So there's a lot of gaps and stuff that bacteria was able to grow in. And that bacteria would actually migrate and work its way up onto the equipment where there it gets splashed by the spray, the guys cleaning.
And then the conveyor leg was built in such a way that it could harbor that.
Yeah, it would
So it started in the floor drain, but it
creep up inside the
made its
tubes.
way to the tube,
Oh, yeah.
and then there was a place for it
to hold on,
to
it's
hold on in the
It's
leg.
dark and wet, and it just loves it.
And so what would happen is they have the QA people would come with their white Q-tip, you know, I talk about all the time, and swab the legs on the conveyors, and they would fail
Because
because they had bacteria in them.
they were using tubing. Although that was
Yeah.
you said that is your favorite to use because of the strength, but not because of
It
sanitary.
doesn't work very
Right.
good for sanitary design.
And at this point, there still are a lot of conveyors and equipment out there that were made out of tubing. For a time, it was great because ignorance was bliss. You know,
Yeah.
we didn't really know if that was a problem. But it's been about 15 years or so that I really try to avoid using any kind of a tubing.
Does it make a difference on the type of food? Because like we're in potato country,
Oh,
farm
sure.
country,
It does.
and you know, I would imagine that they're moving potatoes out of the field. That's not sanitary equipment. We're talking about processing, dehydrating.
And it depends on the facility. And what determines it is if the food's ready to eat or if it gets cooked, if there's a cook process after it leaves that point. And potatoes always get cooked. They get
We
fried.
actually just built some conveyors, and we did use square tubing frames because, again, it's just so much easier to work with. But it's for raw potatoes right out of the field. Some of this equipment literally was washing equipment to wash the dirt off. It's not such a critical deal at that stage of processing. But
Because it's
later
going to go
on,
into a great big storage unit.
Yeah.
What do they call those potato
And it's
warehouses?
not-
Yeah, spud cellar.
Yeah, spud cellar.
it's not even when they're done with what they're doing in that process. It's not clean. It's not fit to eat yet.
So you go from that process to the process where we were working on a line where it's a ready to eat spiral. That's the only one I can really relate to. And even the clothes that you wear when you go into the room when they're in production protects you from outside contaminants. And that's where, there was the biggest concern of bacteria, because it gets put in a box and shipped out to the store, and people buy it and eat it right away. And so there's no cook process. And so it has to be very clean, very clean. So sanitary design is like at the height.
Mm-hmm.
there.
And that's in the food. But then, like meat, though, do you guys do much for meat?
We've done.
That's another kettle of fish.
And that,
Yeah,
that one
because-
you have to, we built some decks for them, and I never thought we'd build handrails out of angle iron, but we do. They cannot have a closed tube,
Okay.
round or square. And so
And that's anywhere in the process.
anywhere, the whole
So
plant.
everything is angled.
Yeah, there's
Yeah.
and everything has to be tabbed.
So what do you mean?
seal
What do you
welded.
mean by tabbed?
Well, to bring stair treads together, or where sheet metal meets, you have to, if you're not able to seal weld it all the way, you just weld it ever so often and cut it to where there's a gap that can be washed through.
Because when I watched them put together the conveyor, you designed it so that it looked like jigsaw pieces,
Yep.
puzzles coming together.
Mhm.
Is that what you're talking about?
Yes.
Kinda?
Uh-huh.
It's
Yeah.
a tab.
That really serves two purposes, though. That's kind of a neat deal. We make it so that there are slots and tabs that fit together, so you can't put it together wrong. But at the same time, you're only welding that little tab part, so there's a lot less welding. The tab is usually longer than it needs to be, so it ends up making a big gap between the two pieces that are joined. And that gap is what you want so you can clean through it.
Oh yeah.
Yeah, it
So you don't
doesn't-
want it snug.
It
because
doesn't
then-
harbor anything.
Yeah.
Yeah.
So you leave a little gap, and so really it's those tabs then that you really have to worry about. So on this one here,
The tabs are seal welded though.
But
Oh.
but there's
So
no
we'll weld
when
them all the way
when you're
around.
done seal welding that tab,
And it's
on
not
both
that much
sides.
welding. And they'll weld the whole thing, and there's it seal welds it. Usually it's pretty close to 100% weld, where there's no gaps and there's no places for bacteria to get in there.
so back to the meat plant then. So you did everything in angle. So you guys actually bent that? Is that what you?
No, we used structural angle.
Structural. Okay.
But
We
yeah,
did,
like you
we
said,
did bend a lot of
we
it.
have bent some of it. But the structural angle, and so there's just a little more work in coping it and making it, work. No sharp points
Yeah.
for hands to get cut on. And
So is this all out of stainless?
yeah. Generally, stainless and sanitary design for food go hand in hand.
Yeah. I know they've approved titanium, except who can afford it?
Well, that and aluminum, what you find with aluminum or titanium is the cleaning solutions that they use, the chemicals that they use, actually eat the aluminum.
Aluminum used to be great. I used to make a lot of parts out of aluminum until the cleaning procedures changed in the factory. They use more chlorine, I think, now than they used to. Now aluminum's out. You
It just eats it away.
you just
And if it's
use
anodized,
aluminum.
if it's an anodized aluminum, which is a coating that they'll anodize it to, it's like a kind of almost like a powder coat, right?
Yeah,
An anodize. It's just the process.
yeah.
A lot of aluminum is anodized. Well, that chemical just eats that off and it starts chipping, and then you got problems because
See, now you have
that's
all-
getting into the food. The chip.
Oh yeah.
The chip.
Plus it leaves a pocket.
Oh yeah,
So it's a
bacteria. Oh yeah.
It's a real rough surface that can It's real hard to clean, can trap bacteria.
And it's funny because even the suppliers of buyout parts like gearboxes and motors and things, they're like, oh, it's anodized, it'll be fine. No, it won't. And they're like, oh, no, it's been tested. Well, not at this. We have to put our foot down and say, no, that's not what we need, because we know what them chemicals will do to that material.
Yeah. So you just touched on another part of this, because we're just talking about, angle versus tube. It really starts with you guys knowing what you're doing.
Yeah, what works and what doesn't.
Yeah. So even the guys who own the food processing equipment, they may not know what works. They just know they need a piece of equipment.
Oh, sure.
It's going to move, these potatoes from here to there, and it needs to be sanitary. But they don't really understand all the FDA rules.
We just went, as you know, to the Pack Expo there in Vegas, and walking around looking at some of the equipment, Steve and I were like, oh, that's not sanitary, that's not sanitary, that's not going to work. A lot of these engineers in the plants don't understand it until it's a problem, until there's QA people are going, hey, this ain't passing the swab. Everyone's got a lot to learn on it. You say, well, we got a lot of experience on it. We're still learning. We're still learning every job. We learn something on, well, we should do this better next time, or this,
But every plant's different, though.
Oh, yeah.
That's why they
and
come
that's
to you
the thing.
guys.
You kind of have to set your brain, okay, this is a spud plant. They don't need it. They don't need it this good. Or this is a meat packing plant. We got to bring our A game,
Yeah.
Well, the potato plants are changing. You go in some of these potato plants that have old equipment, and you can't believe how rough and rusty, and put stuff back in that looks like that.
No.
It's always
Yeah.
stainless, and a lot of times it's truly sanitary design.
Well, I've spent some time, one evening on one of those great big farms up in Mud Lake this year, riding on the tractor, getting the potatoes. They put me in the truck, took me into the big spud cellar, and they have quite a bit of technology in those cellars nowadays.
Oh, yeah.
And they were taking pretty extra care. I mean, their equipment was old, and the guy that was giving me this grand tour that night was saying, we should update our equipment, because he was showing how it's rough on the potatoes, causes bruising, all this other stuff. I did think about, you guys could build equipment that would make that process easier for them. That's part of what you do.
Just understanding what the customer's needs are, I think that's the biggest thing. What we have found, and I've said this before, is it's pretty tough to take that old equipment that was built back in the day and make it sanitary. Because the sanitary design starts with the design, and from coming up with the concept and what they need, figuring in those designs, and the sanitary design starts at the beginning of concept. It's very difficult to take an old piece of equipment and make it work.
I mean, some of these plants too. I mean, you walk in, they've been in there a long time. So you can't just say, that's tubing, let's cut it here, put angle on.
You can't do that. It doesn't work. No, it's cheaper just to start over, really, because you can band-aid it forever and still have a problem, But,
I guess as soon as you make a connection, you're going to have sanitary issues.
And we're building some equipment right now for a potato plant, and we're really trying to be careful of what gets seal welded, what gets, and make it more sanitary, because everyone's moving more in that direction. And it all comes down to, at the end of the day, no food plant wants their name in the news stating that they got all these people sick. That's like number one priority, that they don't get anyone sick.
Oh, yeah. That could be the end of their business.
Oh, sure. Yeah, it could give them look what happened. I can think of Chipotle was one that I can think of. That we had the peanut one. Wasn't there a peanut factory?
There was a peanut factory that I think someone went to prison.
Yeah.
Over that.
Wow.
Yeah.
It's important to understand, here's where you use angle, here's where you use tubing.
Oh, man, yeah. And that's what's brought it to forefront, is not contaminating the food, That's why it's so important to select the right fabricator and the right designer to do these projects, because you can have one conveyor, one piece of equipment that's causing the bacteria problem, and it infects the whole process.
The whole plant can go.
Yeah.
Because that stuff travels fast.
Yeah.
What's your advice then on choosing a good fabricator? We've been talking about this. It's just one little aspect. One, just the tubing versus angle. How do you make that choice?
That's a good question.
This
I guess just understanding the fabricator's experience.
I think that's mainly it. Is
Experience
just
and attention to
experience in a food plant
Uh,
and attention to detail.
Also references. I've had plants ask about other contractors, if they have experience in that. Your reputation, I think, is huge too, as a contractor. Understanding that we have plenty of satisfied customers that we solved these issues for, solved problems for.
But now's a good time to toot your own horn, right?
Well, yeah,
Because
yeah.
you guys have, you've been around 26 years.
Yeah.
And so you've gone through, hey, we're going to make something and it's just for the potatoes or digging them out of the field, all the way to the most delicate type food, the meats and all that kind of stuff. So you've learned over the years. So they could actually call and talk with you.
Oh, yeah. I think a conversation, even a site visit, we'll go see what they got going on, and usually it all makes sense. We can come up with a solution to help them once we see their process, what they're trying to accomplish, what are the problems they're having. I was going to ask too, Steve, we've solved a lot of problems with bacteria, and I don't really know the full process like you. Did it solve it for good? Were we successful in solving a bacteria problem for good and not ever have that problem again?
Well, I doubt it. There are just so many nooks and crannies, in any process, in any factory. There's opportunity. Anywhere you look, I'm sure there's opportunity for bacteria growth. But really, the best we can do, and what we do, is we just try to reduce the probability by anything that we build to put in there is going to be better than what was there. And it's just a continual improvement. And so it's just reducing the probability that they're going to have a problem.
Because even with angle, like you mentioned, if you drill a hole in the tube, or maybe it was you, Steve,
Yeah.
and the amount of box on it, now you have a problem. Even with angle, they drill a hole in it because they want to hang something, and they put a little bolt there.
Mm-hmm. Yeah.
Now they have the problem.
That's a place where bacteria can be harbored.
And if you don't have a spacer behind what you're bolting on there, you can't wash through it.
Now there's two surfaces
touching.
touch, but are not sealed.
So do you guys do education with the processors? The people say, because they come to you and they hey, we need something, and you have to go in and say, this is what you need. We can do what you want, but you guys need to understand what you're asking is a lot different than what
There's been more than one time on a walkthrough I'll be like, you don't want to do that because it's going to grow bacteria here, and they'll be, you're right, and so we'll suggest things, maybe turn them in a different direction.
There's no way that the fabricator can really understand all the things that need to happen in sanitary design, because you don't have a way of actually setting one up and then cleaning it repeatedly day after day after day after day, so that you can say, okay, this is where we're having the problems. You set it up and you do the best you can, and then next time you learn from it and so forth. Is that an accurate statement?
And I think too, like you touched on it, Steve, being able to clean it, making it so where they can wash all that bacteria off every day, because that's what they clean every night usually,
right,
or every time they change processes.
In a USDA facility, I think it's they need to do a cleanup process every 24 hours.
Yeah.
In a non-USDA, I don't think they have to do it as often, but I think a lot of places do anyway, just because that's kind of a standard.
So making it so it can be washed through, cleaned every day, keeps that bacteria away.
That's pretty hardcore. I mean, that's when you talk about designing something, you're going to be spraying down in high pressure and with chemicals every day.
That's a whole other issue too. Is how do you make your stuff stand up to that much water?
Day
in and day out in the high pressure water.
I've seen NEMA 4 electrical boxes full of water. 4 is the highest.
I think so. NEMA 4X, I think.
Is the highest rating for keeping water out.
And it's full of water.
Oh, yeah, I've seen them full of water.
Because they just blast it with high pressure, and it's just
it gets that 600 psi or 300 or whatever.
Wow, that's crazy.
Yeah.
Well, I think it's been an exciting adventure for me, just learning the sanitary design. And I worked with Steve first before he worked for us
Oh,
as a contractor, and we worked together on a lot of stuff and solved a lot of problems. And I used to joke around that those guys with the white Q-tips were my favorite people because they created so much work for us. But it all made sense what we were doing and why we were doing it.
because your history, you started in the beverage industry, which that's a whole nother beast.
Oh yeah, that's
because
clean.
Clean. But still, you're dealing with tubes then because it's got to be a challenge. Like, how do you keep that sanitary?
Yeah, and I think once you understand the concept, just some of the things like angles and square tubes and tabbing things together, it really, once you understand, you can identify problems or things that are going to work really quick.
Yeah, it doesn't take long.
No, it doesn't. You can see it and you're like, oh, well, that's not going to work. Or, hey, that's going to clean real well. So it's been fun to learn, that process. And I seen a meme the other day, because I see it, as a fabricator, everywhere you go, you're looking at stuff that's built, right? And I seen a meme that showed somebody standing looking at this pretty waterfall and there's mountains and things. And it says what I see, and it's the mountains and the waterfall. What I see as a welder, and there's a handrail with a bad weld right there on the handrail. And that's what I'm looking at. And not the
waterfall,
yeah, it's
the
like,
scenery.
How did they get away with building such a crappy handrail here? And so we see it every day, and it's like, I ain't walking on that. Do you see the welds? But it's just something that gets seared into your brain, and you.
But that's what they want you to do.
Oh yeah.
In this industry, they want you to be able to walk in and go, "Wow, there's problems here," or "Wow, what a good piece of equipment you have."
Yeah.
Either way, they want you to
I
be
think
honest
either
about it.
Steve or I could walk into a factory, say someone's got a problem with some bacteria, and they want us to come look at it. We could walk in and identify the problems real quick.
Pretty quick, yeah. Yeah,
Excellent.
I think so.
Both of us, either one, just going in and looking. Well, here's your problem. You got to change this.
We've had a lot of experience at this.
Really?
I mean, for a couple of years, it seems like all we did was fix problems.
Yeah.
We didn't really design new stuff. We just tried to
Fix other people's problems. And that's got to be a pain. Because
and I mean, I remember one on the flour tortilla line, okay? And it was so funny because we took this belt off that all this dough is coming across and going right into the proofer.
you're talking like dough you bake. It's
it's tortillas, but it's the round ball first. And we took the belt off of that thing and we put, for whatever reason, there was a foam pad. Do you remember that?
Oh yeah.
And we
soaked with water.
Yeah, it would get soaked with water and flour every night when they cleaned. And so we peeled that thing back, and it was like a whole new city colony of bacteria. we were just like,
oh no,
what happened here?
And stink.
Oh, it was bad. And here's the food. But this food came right across that for months. Steve got right on the computer, went to work, designing something different that was going to work differently. And we fixed that problem. And that could have been a huge problem if it would have ever got anyone sick or had bacteria. But that was a battle.
But the other thing, and this is changing too, it used to be, well, any baking process has historically been unbelievably bad. You can find green things growing because there's a lot of flour.
Flour grows bacteria so fast.
And,
really?
When it gets wet,
it used to be made out of carbon steel, so it'd rust, and then flour, and then water, and has traditionally been just awful stuff.
Yeah.
But the thing that saves it is the final step is it goes through an oven.
Oh, okay.
And then it gets put in a microwave when you buy it.
Yeah.
So that's what's been That's what saved that industry, I guess, is just the fact that it gets cooked.
Yeah, because it gets
And in
sterile
this
again.
tortilla process, it was the same thing. The last thing that happened was the tortillas went through an oven, what they call a kill step. But that's changing. The kill step is now not really being accepted as a solution to the problem.
Yeah.
No, not when you can peel it back and you can actually see
Well,
and
and
smell
just
the bacteria.
saying, well, it'll be fine. It's going to get cooked anyway.
Yeah.
You can't say that anymore.
Yeah.
It's got to be fixed. So there's the problem gets fixed before it goes through that.
I mean, I remember bakery equipment that new stuff would be carbon steel, but no more, not anymore.
Yeah.
Bakery equipment is, I think they have a long ways to go.
They
because
do.
That industry just never did.
Because I know, like we've talked about in the meat industry, in the processing industry, I mean, they watch it close. It's,
Well, we just did a job at a bakery where we had to replace a deck. I don't know if it was the FDA that regulates bakeries, but
That's right.
Mm-hmm.
they were requiring them to unscrew the deck plate and pick the deck plate up off the frame
And clean it.
clean under it
And it was a carbon steel frame.
every
Oh,
night.
really?
Did that happen
Every night. They had to do it every night, and it was costing them tons of money. And they had this problem. They didn't know how to fix it. And they're tons of man hours
The
pulling
fix
that
was
stuff
just
off.
to take the screws out.
That's what they had to
and
do.
Have people spend hours and hours taking this thing apart so they could clean it,
Mhm.
put it back together, and
so they
use
go
it the
back to
next
work.
day.
Mhm.
Wow.
So we went in and built them a sanitary deck that doesn't have to be taken apart.
Yeah.
You can wash and clean.
They just spray it down, they're
Yeah.
good to go.
Mhm. And oh man, they were tickled pink. And it's one of those things where someone hears this and they're like, well, geez, what do I do? Well, we can come in and do an evaluation. We can assess your problems and identify areas that you need to work on or fix. That's what we could do. And a lot of times it's fabricating something different. But we're more than willing to go to your facility and take a look around, see what can be fixed. It's pretty easy to identify the problems. This particular problem with the aluminum deck, it was just setting flat on a square tube,
Yep.
and so there's a pocket there
Mm-hmm.
where bacteria just grows, and it migrates.
Oh, yeah.
That's one thing we don't realize is bacteria.
It likes
moves.
to move. It likes to
Right.
grow and spread out. Yeah.
Mhm.
And that's the biggest issue. Final word, Steve. Angle 2.
Angle every time if it's food.
Every time if it's food. So basically, they need to come and talk to you guys and say, let's look at what you're doing. Then you can determine angle is sanitary, tube is structural. You may not be using it in a sanitary condition, so it'll be fine.
Yeah.
The problem is structural tubing, say smaller stuff, has been used to fabricate conveyors, the thing that's closest to the food,
Mm-hmm.
and that's where you can't do that.
Yeah.
And so, it used to. I mean, I remember seeing belts running on square tube, the food belt, and so can't do that anymore. And so you got to use something different, solid plastic, for
Yeah.
wear strips.
Mhm.
The plastic's actually the whole support, or those kinds of things, and get that structural steel out of the conveyor design.
It's a challenge, isn't it? Because you want to use it to add
is.
strength and
It is a challenge, but we're pretty good at it.
Yeah, we're getting
these
good at it.
days.
yeah.
Yeah,
And we're getting things kind of figured out.
yeah.
I noticed you did a lot of what is it when you bend the metal? What do you call that?
Forming it.
Forming it. You on what when I watched, you had a lot of forming.
Mhm.
I assume that was giving it structural integrity.
Exactly.
To bolt things to it.
Yep, exactly right.
Yeah, you bend it. So the legs that we made for a lot of our conveyors now we cut it flat pattern, and we can put the holes, if it does get bolted with spacers, when it's bent, bend it into a channel, and it's really strong. It's pretty strong.
Yeah.
It's
And
a good way to go.
So it's kind of lightweight and strong
Mhm.
if you're taking a lot of that off. So.
And you can wash through it, clean it.
Excellent. Okay, Chad, tell us where we're at.
So we're at Industrial Metal Enterprises in Blackfoot, Idaho.
Okay, commonly known as IME.
IME.
So look for the IME signs on all this stuff.
That's right, IME, and we'll will make your job easier.
Okay, thank you guys. I would like to thank Chad and Steve for visiting with me today about angle versus tubing when it comes to food processing equipment. They are extremely knowledgeable. If you need more information, please reach out to Chad at Industrial Metal Enterprises in Blackfoot, commonly known as IME. Next topic will be the machinery we use in order to create sanitary food processing equipment. So stay tuned for that. These guys have a tremendous amount of knowledge, and they will be giving you some valuable information when it comes to sanitary design for food processing equipment and the machinery we use. Thanks, and we'll talk to you next time.